Welcome to Wickerson Studios. My name is Michael Wickerson, and I have just completed Chapter 4 of the Python one-liner textbook and translated it into very unique scripts in Grasshopper for Rhino 3D and created a series of many user objects that I've categorized without icons into basic, intermediate, and intermediate advanced. And I'm going to focus on the intermediate advanced section of this. And this is probably exactly that, at least if I thought about where it was on the level of my understanding. Now, it may be basic to other people out there, but it might be completely abstract and advanced for others. What I'm going to do is I'm going to go over two scripts that I've generated because they do climb pretty large, are the Chapter 4 on machine learning, and 10 scripts which are numbered here. The first set is here, which is numbered 1 to 5, which ends in neural networks, from linear regression to neural networks. And the second set continues from neural networks all the way through to multiple decision trees or ensembles or random forests, if you want to call it that. And with each one, I've set it up, and we'll just take a look at the last one, for example. I've gone in and brought in basically the classifications with random forests. There's an example. There'll be a node that's a user object, and they're up here on my ribbon tool. And this is what I'm supporting my Patreons with through private repositories, that you can bring down all these user objects into your ribbon tool. It's a different form of kind of, I guess, development. I'm not compiling these, so all scripts within here are visible to learn. And you're going to go right through from the imports and how you can use the Python remote node plugin. And that's what I'll start with in the series. I am going to go back to this, but I owe my Patreons the last 4 scripts or 5 scripts. And so we're going to cover that pretty quickly. And what I'm doing as I run this is I'll do a sample hard-coded, and then I'll do something much more parametric as I run through. And I'll apply it to this one. The code will change, and the examples get a little more coded, customized by me. And then I pull them into a data visualization at Wickerson Studios to do something funky. So let's just go back to Rhino. You can see what we're doing here. It's not too exciting to look at this geometry, but as we play through the different iterations, you can see you're basically structuring a pretty interesting building unit that can generate on different levels. And it's not different heights. It's kind of pretty basic. But what people are used to in Grasshopper working parametrically, you're actually driving this by machine learning algorithms. And of course, there are also being driven by a randomness that's associated with that prior. So what I want people to think about is how you end up producing something in Grasshopper, or the visual artist, which is what I've dealt with so long. Stop looking at the solid. Look back to the surfaces of that solid. Look to the lines that are lofted to make that surface. Look to the points along that line that define that line. And look to the attributes of that line as number or XYZ coordinates, and then think of the number. But prior to the number, go back into thinking of the algorithms that can produce those numbers. This whole algorithm using machine learning is a bit ridiculous, like most of these primary examples, because it literally is just producing the number series of 1, 2, 3, or 1, 1, 3, or 3, 3, 1. And I'm using that data afterwards to show a very simple visualization of how a random forest can be conceived and understood. So for the visual artist or the visual person, I think you'll find these 10 examples extremely helpful, because not only are they here, I've also written out of the text the key ideas of what the notes are on that and what the code is doing and how it works. And then I do a little summary in the end of the paragraph. So literally this section, these 2 scripts, if you look at them, will teach you everything from regression, neural networks, all the way through decision trees, SVMs, and then into basic statistics. It's going to get crazy after this in the next series with regular expressions, which I am going to apply to the text the way things go. I think that's called, or it's a Dr. Seuss book. And basically the idea that you get so good at something, you're the only one playing it. And I think that's a great text to use as an example. And this is going to be highly technical compared to us relying on all these one-liner script algorithms. So that said, I'm going to pull off probably every visualization currently. Just take it to disable, open up the Grasshopper screen, and show you by the end of this script, you are generating a Python script that I have not made into a user object, but looking at machine learning, scikit-learn, This script, you can see, is learning, and it's pulling up on my other screen, basically how to import what you're pretty much used to doing. But as soon as you import that Rhino Grasshopper Python remote node plugin, you've got to find a way to start working with how you can start incorporating all of the machine learning libraries, their what are they called? Constructors and functions and methods and all of those things. Because you'll end up writing them into just one-liner scripts. And I've got a few examples up here to show you how simple the scripting is if you rely on those. Now, the real trick is where we begin. And the beginning of it is literally here. And this is what I want everybody to at least be able to engage with and do. And that's to get this up and running, which is the ghPython remote node. And you can see what happens. You find a location on your computer where things are. You activate it with run, but you have to find a way to bring in everything you want. And you can see here I've gone from NumPy all the way through the ensemble of scikit-learn. It then shows you what's loaded if it's running well with no errors, and it shows you how you're going to have to import it when you bring it into your script. An incredible node, and I'm very excited about how that's developed. I had something back here, it was just a script on branch management. If you want to jazz up all of these scripts, I've got a really nice script, which is a tree generator, which I'm very excited about. If you look at it for those Python fans and you wanted to start thinking about intermediate advanced branch management, you can see here I've got a nice little short script I pulled offline to produce and control scripts. So lists of lists of lists. So that's really where I begin with. Now we're on to I think the second example of this. So it's probably best to go back to the first. But in going back to the first script, it's the same type of thing, but you'll see at the beginning I wasn't using everything. I didn't need everything in here. And you have to have this on all of your forms because whenever you run it, I'll show you basically, as we enable it, I was using less libraries in this one. But as I turn it off and then turn it on, you'll see it runs in your, you'll have to go back to your command line. You have to run and get all those libraries loaded up. If that's working, you're kicking butt and you're ready to go. Except I just turned it off. I shouldn't have shut it. Let me just go back into here and activate it again. And I'll just tuck it down here along the bottom line. So very exciting. So to learn how to get this up and running, I will cover for my Patreons and I can break it down, but I think you should have enough skills to be able to, let me jump in here. I've got a few pages here just to talk about briefly at the start. Maybe I should leave that there. You're going to want to go into pypi.org, and you're going to want to find out how to load and follow through. It's not as simple as bringing in any plugin. You've got to go through here, follow the instruction, read through it, find the examples, and slowly kind of configure in your command line. It will run fairly smooth. It does load up nicely, but you start to learn how to write in libraries with this sticky tool, which I think is kind of interesting, the sticky function or method. And then it shows you a few examples of RPY, and then it shows you how to use tree helpers in case you have to get into doing those things, and online examples. Now, for me, I don't go to the forums and ask questions for people to figure out what I'm doing. I really don't do that. I go to the forum and type in what I want to do and look at pre-existing dialogue that's been written out back 5, 10 years. And I like to figure it out that way because I think you end up understanding it more. So what I have is with these scripts that I've shown you, and I have many of them, I built a GitHub repository of the master one-liners. And I'm still going to do these even clearer. I'm going to make it a little bigger here. I have the basics. I have the basic GH functions all tucked in here, which is from the first chapter. I have the basic intermediate from the second chapter, intermediate from the third, and then I have the intermediate advanced, which is all the machine learning algorithms that are tucked in there. And then I have my master files, which are the summaries of each one of these sections. And I keep updating this as I go. Now, if you're interested in this, I do keep it private, and I share it with my Patrons on the first tier level of $3 a month. But in here, you're going to need these files, but you also need the user objects, which are all of the user objects I've created when you go in this file and you see those WS icons. I don't leave them as Python, but I don't compile them. So you literally can go in and open up every one of these scripts if it's something you want to take a look at. When you double click on it, you can see that the interior of all those scripts. And I brought these out of the ghPython, the Python one-liner book and put them in the Grasshopper. And I think I've provided incredible service for people that want to start using machine learning to drive geometry and forms within Grasshopper. And this is for people that have played around it. It's like people that have learned static modeling in Rhino, have a desire to go parametric in Grasshopper. People who have been in Grasshopper decide to go computational in the Python node and the C# node, and then you realize, hey, I don't have to generate these codes from scratch. I could use things as complex as linear regression, stand on the shoulders of giants, and start driving my geometry that way. Things get incredibly complex quick, so all of my examples are really, really primary ABCs, 1, 2, 3s. Possibly regular expressions will be the advanced section. I'm very excited to see where that goes, and more complex algorithms will pop up. So back onto this screen. Those repositories are there. All of my repositories are available. I have many, many free ones out of these 41. I only reserve the ones with user objects for Patreons. And if you are interested in Patreon, you can see right here, it starts at the $3 level. And I don't charge much. I haven't made much on this. I'm not into it for the money, but I think you have to have something invested just to be in here. And it does show me who just wants the basic scripts of all of these scripts that are available for free, but the one in here is the one-liner Python user objects if you want those. The 9 will get you access to every repository and every item in it. And then anything past that is really time spent with me online one-on-one. Not that anybody in the other tier levels I won't correspond via email endlessly. And then I've got an awesome poster for you. The other things are much higher tiers, which are to have, up to 1 hour a week with me, one-on-one on top of your emails. And I do want to thank the patrons, and I will start honoring them particularly. It's growing slowly, but it's been a 1-year project to try and organize these things. The next thing is all the video tutorials that I'm doing, including the one I'm doing right now, are absolutely free and available online. They're not breakdown tutorials. And with this series, if you're interested, please say in the comments you would like to have independent, really, dumbed down introductions, how I'm writing the script. But I'm not one to teach like showing you the cover of a puzzle and saying, let's build this puzzle together. Everything I do in the user components, which are available, are very small constructions working with Lego or with erector sets. I want you still to be able to build pieces out of the parts. And that comes from really listening to Jose Luis's C# algorithms, where he decides, why teach somebody to do the entire Berlin Holocaust Memorial in one node when you can teach them all the elements broken down into units so they can make whatever type of memorial they'd like to make, or whatever type of geometry they'd like to make. So these are all available. If you go into playlists, you'll see this is the one I'm currently working on. Very excited about it. I have almost 40 now in the full viewable playlist, and you can watch it right from the start as it's culminated into this. Just like robotics, this has perked up my analytics online, so I'm going to continue with this series until it kind of washes out its popularity, and I'll move on to the next one. So that's a lot of information, but you are going to want to go in. And what I did was went to power of Python one-liners. That's the excitement of this, is everything is dead simple one-liners. And I use this book, Python one-liners, and that's what sat in front of me. I have never read something this slow. I've never researched it so slow, but I have literally translated it like it was another language into Grasshopper. And that's the service I'm providing while making custom, creative, unique scripts, so I'm not stealing the intellectual property. Nobody has the one-liner or the algorithm to use. None of these are for them solely to use. They're there for you, available to play with. So I'm going to move that out of the way and go back into the script, and you can see what was happening. I would go in, I give a little introduction of what I'm reading. This is the basic Jazz script at the beginning, which I think is interesting. It didn't have too much on it. It just had NumPy through to linear models. But I use that, and there's a couple examples you can load up to see what's happening, even though the data might not be there, but it should run. And then I went in and I covered, in number 1, linear regression. Then over here, I did with examples, with geometric examples, and I started to classify those as Wickerson Studio custom geometries. Logistic regression with sigmoid function. K-means clustering. It's all in here. They're all running in very short scripts. But once again, they're all custom nodes that you have to go on my GitHub. Obviously, I don't want to do this all. It is a learning curve for me, and I don't mind doing that. But because I'm sharing it, I'm trying to find out who's really interested in it. Let me just grab this one and go to enable. So you can find these nodes when you take them and upload them. It's not working because the data's not here. But if I made all the data live, you'll see that node's working just fine. And I've made it so if you want to go in there and you don't like what I've done and what data is being driven by it, you can go in there and change anything about it. But you see the basic bringing in, and you'll see a lot of notes and a lot of examples that I've left in and left out. And some of the scripts have a lot more notes, but in time, I started to really pull these away from that and start putting the notes into the scripts. Like here, I didn't do it in the first 5, but by the end, I literally was writing the notes from k nearest neighbors and how the code works, and then having the example afterwards listed as Wickerson Studio Geometry. So I hope this makes sense. We're going to jump down to the one that I'm most excited to catch my peers up with, and you can see how it's grown. It's grown to all of these libraries. We'll just shorten this, and you can see that my user objects. I'm not really a front end crazy like have to have icons on everything. That's not important. I'm not there for that type of learner. I'm there for one that really wants to get into the logic driving everything, and certainly the data driving everything. I've understood now, and I just want to clarify that if you make the connection between data visualization and data science, data visualization and computer science, data visualization and software engineering, you're going to find this series amazing. I'm a 30-year-old computer scientist dropout with 30 years of building experience that in the last 2.5 years, I picked up the computer and taught myself Grasshopper and found myself going from static Rhino, parametric Grasshopper, computational Python, computational C#, and now I'm going into this wonderful remote node that I'm able to delve into machine learning and data files, which is the next step, which is why I'm beginning with text, to really try and up my game. How does it say? To become more efficient when working with textual data, which is a skill that most Python people they say in the tech is undervalued technique, which can really leverage you as a data scientist. So I hope you're enjoying this. I hope my script doesn't run out. And what I owe my peers is I did generate a very interesting neural network here. And I would just grab that, another example of it, enable. And I have to let that load up a second. And what I did was take what I had ended the last section with on my video on neural networks. And this is really out there for a couple of my patrons because they're asking for it, and I'm speaking to them daily. But I've changed the sample to actually bring in the inputs and then show a couple of examples, and it's all driven by jitter range functions. And this is clumsy and awkward, but it provides a little bit of visualization for people that want to see how the data is broken down and generated. And you can play with anything in blue. You can also play with this. I could probably remove that and say you can play with your number slider here. But in the end, you're generating, if we slide over here, a geometry driven by neural networks that produces this very interesting form here, an arched support, which is something and of course, things like to crash out an awful lot, and the canopy that goes over top of that. So very nice machine learning driven, data driven geometries. And I just did something different with it. I guess here I was playing with, what was I playing with? Move. I think you can quickly just move this in the Z direction and get a totally different geometry. So if you're used to playing around and asking your peers to get in there and play around with the number sliders, I've left them as blue. Let's convert this over to the Z-axis. XZ, I don't know if that's the one I want. There it is. You can lift that up into space. So basic stuff that you remember from working in Grasshopper. So that one's done. And that neural network, I don't think we have to go revisit that to why I made it different. Things are a little slow because I've got a lot of files open. We're going to disable that. And then really get into the first one, decision tree learning, which was pretty exciting to play with. And I covered that. And decision trees are something that are running in here. I'll show basically the script of the basic non-Wickerson customized geometries. But it is running. Well, at least I thought it was running. There's something problem with the array. It might be that, obviously, I might need to reset all of my libraries, possibly. But no, I have a problem here, and I didn't want to begin with that. So it's exactly 2 arguments. I think this is a case when I go into here and take a look. It's asking for something here. It should be running. I've had this trouble before. I might have to reset it and just have it run again. There it goes. Just have to run it again and it'll work. So a lot of times when you go into my files, you have a little trouble. Just open them up again. So what this is doing is taking data. It's taking information that if it knew these type of grades coming in for an art, and I used examples out of the book for this a lot of the times, it will then predict if you had sample 1 and sample 2, what programs they go into. I think it's a choice between art, design, and engineering. So you'll understand that, but to really understand what's happening behind the scenes, you're going to want to read the notes on what decision trees are all about. and I've left those for you. I'm not going to cover these in the video. Then the code, it's a breakdown of what's actually generally happening in the code away from any particulars that are running. Just make sure you close everyone out as you open up another one. And the geometry I'm driving with this decision tree, which I'm excited about, and we'll just activate it here, enable. We'll take a look. I've gone in and customized and made them a little different, but I've also numbered them as examples of those algorithms. So even though this one over here is numbered 15, which is one-liner decision trees, this one over here is one-liner decision tree example, and it differentiates a bit. But in the end, you can always go in and visualize that. And here's another visualization tool for doing that. I think I've made a video on the decision trees, so that's not one of the last 4. But it's totally parametric through the Grasshopper, and it's totally through pushing the data to the functions, to the machine learning script, and hopefully that becomes a valuable resource. So the decision trees I covered. This video really brings me to where I wanted to start it, but I thought it was good to back up and talk about those things a little bit. Let's go back in and say what was the next one we dealt with, which was called minimal variance. And minimal variance is going to break down exactly what that means. And you can think about it as finding average. Some of my script is a little cumbersome in the notes and how the code works here. And I started using random ranges and doing things a little different. So this script, when you go in and you activate it, enable it, you can see that it provides you a little bit more text readability, usually in the examples because it comes from the book. Row with minimum variance is 1, and then the variance is this. And you'll learn about these kind of what variance might mean, what it actually can be visualized as. Not quite yet, but you can certainly open and read the script and learn how to start to bring in exactly what you need and how to run your one-liner scripts. They're available to you in here. So you're depending on everything that's been written before. And then I do a couple of different things with bringing data out and choosing items. The whole time you're working in NumPy multidimensional arrays, which is absolutely outstanding because now you're entering a whole other level of how you're thinking geometrically. And what I'll use as an example, as we get out of here and go into the next code, I am interested in the geometry that I brought into here. So let's activate this and see what I did with the decision trees and the data. I'm going to enable that, and it's just taking a second to load. If you consider the complexity of what's being run in the other algorithms and the other libraries, it's not bad to wait a few minutes for this. But if it does crash out, make sure you're saving your files. Let's see what geometry was generated from here. Here it is. It's a jittering kind of surface node that does, I have a few examples of animations of this, but I think it's kind of exciting. And you can go in here and play. I hadn't quite mastered this yet. I think this stuff should actually be ungrouped. Oops. This stuff should actually be removed from the group, and then it should be brought down here. And because it's the data driving it and I want you to play with it, I'll make a habit of cleaning up these files and grouping them and putting them in a beautiful, I always have trouble with this one, beautiful color blue. So it tempts you to get in there and play around. And there might be something farther along on the data visualization in here that I'll want you to play with some of these variables as well. And in doing so, my x-axis, that's not changing too much. This one's is having an effect on it. Oh, well, it's certainly the diameter. Pretty basic 101 Grasshopper things to play with. But as you chase it back, you start to see that this is having a little more of effect, the data that's being driven. And it might be that you're able to take the random. And let me just jump into here. Sorry. This is always tricky when you have multiple views on. Let's go through here. Get to the last script, which was here. Oops. Hang on. This is the one I want. You can always run that script again, and you should end up with different iterations as it chooses differently. Not sure why. If I've got the right file open, probably. I think I see exactly why. I'll show you why. 1 second. Sorry to get jumbled here. It can get fairly confusing quickly, which is why I use so many examples. I actually want to run this one, which should be the one that I'm playing on. I guess that's it. And if I play with my variations, and I probably best just put on everything visual, and then I don't have to worry if I click out. But I'm hoping by running another test, this thing slightly makes some decisions on it because of the data to change up the form. And if it doesn't run so much through the data being selected, then you'll realize that the data is really being driven a little more by the sliders that are feeding the machine learning function. So let's slide this one down here. There. you start to see the real manipulation of the form. So if you think about data that's changing and driving this, you could see how whatever you want to bring as inputs, it will predict these certain type of outputs. Keep in mind where you are with this. This was the first of the decision trees, minimal variance, and then logically try to figure out and visualize that for yourself. That was a little cumbersome how I explained it, but I'll just leave it at that. That's what the files are for, and for you to play and get in and learn and visualize and also know how to script and use the remote Python node. The next one was basic statistics, which I just wanted to visualize for you what the average, how it relates to the means, relates to the variance, and relates to the standard deviation. So that's really what's coming through here is you're getting these 3 points and you're running the most basic NumPy scripts. So this is kind of 101, easy level of going in there and running these base, which so many people are used to. So you're just building and I'm just building a parametric NumPy array that I can actually have some sliders and play around before I get into it. So with that data, I then went in and I said, okay, here's another multi-dimensional array example, because they show you that as well. So you see the data coming out is much more cumbersome and complex, and that's going in and realizing, hey, I can really work dealing with different axes. So that's an exciting one to have a look at and break down. I would recommend getting the text and following along with that as well, because it does make a lot of sense to the choices and decisions I made. But the visual example to this one, I think it's interesting, the data visualization, as I put it to enable. And we jump in here. It just takes a second. You see the data visualization I was very excited about because I threw it into a more recent Rhino 7 subdivision formula. So if I take this one and make it ghosted, actually, if I take it and make it X-rayed, I think it's a little better. Still a little dark. You can always go in here and use the preferences to pull down the color, make it more transparent. There you go. So you can see what's going on a little more with the subdivision, which people are positive and happy about. But what I like is I can run this through. And once again, I should probably be grabbing these, removing from group, pull them in here, and make them so they're so it's recognized as a little more playful. I will go back and clean up a lot of these scripts for you and make it very easy for you to understand. We'll group and we'll throw that into a color blue. So you're tempted to play around with those, but you can see, just watch that corner, how because of the different ranges, these don't line up. They jitter out and move. You can get some really nice geometries and objects made, and I'm just using a simple grid system, playing off of exploding the tree of data that's come out after I've grafted it, and then using the subdivision tool. These are the most basic Grasshopper scripts I can think about using in Rhino 7, but I'm visualizing something as complex to me as basic statistics, which isn't that complex for the engineer or computer scientist. But like I said, it's been 30 years, and I think it took me 3 times to pass statistics in university, and I needed it for a teachable in math, and then I was happy to move away from it. But I'm kind of a computer science dropout artist that's turned computer scientist. The next one, as I come through here, and I'll just turn this one off, disable, is the second last tree that we're looking at, and the last one's an ensemble. This is support vector machines, which are very exciting to think about. Once again, there's text in it. You don't need a visualization to get to the first script because you're literally just trying to comprehend it from what's been written. So it's choosing computer science in this example from the data, and you're driving it by a parametric array with data inputs that have been brought in, and you're running the fit function through those very simple support vector machines. And once that's up and running, I then take it, I make a more complex version here that's going to drive this function and drive this geometry. Let me grab here and try and grab all of that and turn it on, enable. And this is for Peter John Davis out there. I'm actually very excited to have correspondence with him. Exciting person to have met online, and others on my Patreon. So I will start to kind of bring more thanks towards it. This one's running the same kind of script. You don't need, in this example, this and this, and I'm not going to save it. If you have things here that you don't want and they're just confusing you, get rid of them. That's not doing anything. It's actually moving into this custom node. And once again, over here, all of these nodes are here from those samples, and they're numbered. So there's 24 in here. So you can see there's, at least I thought I had 24 in here. 4, 5, 6, 7. I have 25. I guess I have one more example in the end. But this is the script that becomes a little more complex. You can see much more libraries have been imported, parametric, but running that single fit function. And then I do a lot of playing with simple Python range functions to pull out, more than one piece of data. So I don't just want the final data; I want a whole bunch of it. So that's kind of interesting what I'm doing in that script, and that's not in the textbook. So this geometry, which is being driven, if I jump over here, I think is exciting from support vector machines. Once again, the breakdown of what's happening and what that means as a support classifier might be a little confusing, but they're notes for me to remember. Sometimes I've typed these into the notes, but I think it's basically good to just leave them outside as big kind of point font text, and then how the code works and what's happening. There might be some interesting information in there you don't want to miss, and it always prepares for the next piece. So let's take a look at what geometry's here. Oh, this was an exciting one. It's kind of like a spider-like form. There's a little bit of problem here in the center. But otherwise, I'm trying to get these scripts to output like single or multiple closed breps. So I want things really ready for fabrication and ready for printing. So this one's kind of exciting to go through. I think I have a seed that I can play with. The range. Let me take it through a seed animation of 50 point. Actually, let's just do a short 12 and just see what happens in that information as it runs. Hopefully it doesn't crash out. Nothing in my seed, so hang on. That would make sense because that seed was not the one that I wanted. Let me grab the seed here and run it through here. I was on the other file. Animate, let's do 12. You can see how this starts to do-si-do and do some interesting things as thinking about different geometries. I'm in conversation with another fellow, Arwen Hitting, who said something very key in my life. I said, do you lose control or do you gain control with machine learning? He said, absolutely gaining control by setting up my own parameters. So I think it's a wonderful tool. You can get in here and do some grasshopper manipulation as well. And I think I won't update this in the end because I don't want to lose those little things that I cut out just for this tutorial. All of these files, like I said, they're up on the GitHub through Patreon, the user objects. But once again, nothing will work. It's like not having a plugin. That's why I tuck them into these Wickerson Studio custom user objects, but I don't compile them so you have full access to get in there and play with them. I know this one's running on a little long. I apologize for that. I usually don't do videos more than 5-10 minutes. Let's take this to disable. And then let's take a look at the last script, which was pretty interesting, and then a little bit of summary of where we're going. The last one that I put in was a classification of random forests, and this one I left is just the example out of the book, which I don't want to like have these online so much until I customize them so they're away from the content exactly in the text. So that's why I've tried to do something creative with each one. But this is a random forest, which is pretty nice. That allows you some interesting things. A little subtlety in here is you can pick how many forests. You learn how to code better. You understand code because you're looking at it as one-liner script. You're learning how to slice. You're learning a lot of efficiency, but that comes with the earlier videos and the more basic and basic intermediate scripts that I have on here. Keep in mind, I'm only showing you the machine learning intermediate advanced scripts. This is nice because you can tuck in the random state 1 right here to hold the seed at a certain value. I thought that was interesting. So there is a little bit of information here, but if you didn't want that, you can't just hashtag it out here. You can pull it out like this, knowing that you put it back in. You just wouldn't know where to put that. So I think I used an example later on that you can run it like this. It would be the same, but I'm going to go back and, leave that one in, test it, and that one's up and running. So as long as it's running and your script's going well, then I would try and delve in a little bit farther to the geometry. I'm very excited about this last geometry. I find it fun. Usually I forget to save and then I'm like, oh, I got to do it again. But I don't mind that because I end up creating another geometry that I like more. This one I went into the same kind of range function of controlling my data entries randomly. The data that drives the algorithm, which drives the data, which then drives the numbers that drive the points that drive the the geometries of the old grasshopper node. Pretty exciting stuff. Let's do out of this one, and keep in mind this is a sense of ensemble. I use multiple techniques, and they try to say that this is the best one for if you have to get the job done. Great to meet a deadline, a bit of everything. And my spelling I probably need to correct. So let's just take a look and see what was generated there. I like it. It's like a building using region unions. I try and optimize my grasshopper scripts better and better to do more work online before doing surfaces or curves. And you could get in here and flatten and raise and have fun with this. But what I like about this is, depending how many distinct things are here, you take a look, you're generating as many distinct closed breps within this. And very exciting pattern. I like doing geometries like this. I find it very playful. The domain can change if you want to go in and play with this. But once again, the main sliders would be these ones, which are the results divided. If I start to slide through here, you can see you get, let's go into here and grab an animate, and I'll just do 12 quick ones. You can always grab these PNGs or JPEGs out of here to generate a little GIF or animation that makes sense and visualizes what you're learning in machine learning. I think this is incredibly helpful for the visual artist, and there's no chance in a visual arts school that I'm going to have an easy time in the grad school in my courses, the human-handed digital sculpture, computational studies, algorithmic design, if I don't start visualizing things as abstract and complex as these wonderful, giant libraries of machine learning. So I hope you enjoyed that. I hope it made a little sense. It's a longer video than regular. I slowed down. Let me know if you want me to break every one of these sections in here and in the other script, and also the precursors of how to do some of the earlier videos into flat-out tutorials. But I really reserve that for one-on-one time, for emails back and forth with my patrons. I think it is kind of a waste of time for me to do it open source on everything on YouTube. Who's actually watching those videos? But for those that sit down, invest a little bit of sweat in the pot, I think you're going to find this incredibly helpful tool. So it's not a course, but it's a long discussion. I hope you find it helpful. I hope you watched it. And we're all working on the same human project. Thanks so much. I'm going on to Digital Futures to check out what's happening today. Thank you again.